Hi, welcome again to this lesson on Laplace transforms. Last lesson, we discussed yung introduction sa Laplace transforms. So, nagkaroon tayo ng 3 examples dun sa lesson na yon. And then, today, we'll be discussing some important properties ng Laplace transforms na magagamit natin sa pag-solve ng mas komplikadong mga equations. Okay? And then, we will try to solve some Laplace transforms dun sa mga susunod nating presentations. Okay? So, let's start. So, let us recall yung definition natin na Laplace transform. So, the Laplace transform of a function f of t is equal to capital letter F of s. So, again, ulitin lang natin, meron tayong input na f of t na function at meron tayong output na f of s. So, kaya siya tinawag na transform kasi nag-iiba na yung ating variable pag na-transform natin siya. And ang kanyang definition, it is the improper integral from 0 to infinity of e to the minus st times the function f of t dt. Okay? So again, ito yung gagamitin nating definition sa pag-aaral natin ng Laplace transforms. So, pakitandaan. Meron tayong 3 properties na i-explore today. First, we have the linearity theorem na importanteng property ng mga Laplace transforms. Next, we'll discuss 2 shifting theorems na magagamit natin sa pag-solve ng mga Laplace transforms. And then, the existence theorem. Kung bakit tayo nagkakaroon ng unique at kung kailan tayo magkakaroon ng Laplace transform sa mga equations. So, itong existence theorem din na ginagamit natin, pabalik. So, meron tayong dahil nakakakuha tayo ng Laplace transform for a specific function, f of t, meron din tayong tinatawag na uniqueness theorem na para maibalik natin yung transform natin into the original equation. So, next. So, let's discuss yung linearity. Ano ba yung ibig sabihin ng linearity? Consider we have 2 functions. A, f of t. So, ito is a function f of t na merong kasamang constant a. It is added to another function, g of t naman yung kanyang notation, and meron siyang constant na b. So, ang sinasabi sa linearity theorem is that yung mga combination ng mga functions is pwede nating himay-himayin ang pagkuha ng Laplace transform. That is, Laplace transform is being distributed doon sa ating mga functions na ina-add or sinusubtract. So dahil hindi pa natin alam yung linearity theorem, so gagamitin natin yung definition natin ng Laplace transform to prove na yung ating linearity theorem is applicable yan doon sa mga combination ng ating functions. So, in this line, meron tayong Laplace transform ng addition ng ating dalawang functions. It is equal, of course, sa improper integral from 0 to infinity of e to the minus st times nung buong function natin. Okay? Yung a f of t plus g of t, which is nakalagay dito sa unang line. So, that is dt para makompleto yung ating definition. So, ang sabi sa linearity theorem is dahil meron tayong plus dito, dinidistribute natin yung ating Laplace transform sa kada component. Okay? Dinidistribute natin yung ating Laplace transform dun sa kada component. Therefore, yung ating Laplace transform ng combination ng dalawang function is now equal to the Laplace or to the integral of from 0 to infinity of e to the minus st times a f of t dt plus the improper integral from 0 to infinity of e to the minus st times bg of t dt. So, parang dinistribute natin yung ating Laplace transform na parang constant. So, yan yung kinalabasan niya. Ito yung linearity theorem. So, therefore, pagka ganyan yung itsura ng ating equation, pwede na nating i-simplify yung ating equation, right? So, In this case, nire-write lang natin siya na mas maayos. Inilabas natin yung mga constant, like yung dito sa first term natin, yung a, nilabas na natin so that lalabas na lang, ang makikita na lang natin is yung integral from 0 to infinity ng e to the minus st f of t dt plus b times the integral from 0 to infinity e to the minus st of t of t. So in this form, makikita natin, pwede nating i-rewrite yung ating integrals, okay, pabalik sa notation ng Laplace transform. Therefore, we can say that the Laplace transform of the combination ng mga functions can be distributive in nature. So, pwede nating i-distribute yung Laplace transform sa kada term, no? So, nakikita natin na Laplace transform a times f of t plus the Laplace transform of b g of t. So, parang hinihimay-himay natin yung pag-solve natin ng Laplace transforms, which will be very helpful pagdating ng mga pag-solve ng Laplace transforms ng mga polynomials or yung mga mahabang equation. So, yan yung first property, yung linearity theorem. Okay, pakitandaan kung paano yung ginagamit. So, next, we'll go to the first shifting theorem. So, sabi natin kanina, we have three properties ng Laplace transforms. Meron tayong linearity, and then meron tayong shifting. Sa shifting, we have two. Meron tayong first shifting theorem, the S shifting, and then meron din tayong second shifting theorem, or yung ating T shifting. Okay? So, discuss muna natin yung first shifting theorem. So, ang sabi, again, the Laplace transform of f of t is equal to capital F of S, right? Ang sinasabi naman sa first shifting theorem, pag yung ating function f of t is multiplied to this term, e to the at, pwede nating isolve yung kanyang Laplace transform na parang sinishift lang natin yung ating S, kaya siya tinawag na S shifting. So, titignan lang natin yung exponent ng e, and then yun yung i-introduce natin dun sa S once na makuha na natin yung Laplace transform. Okay, so let's illustrate this theorem through this example. So, we know that the Laplace transform of cosine omega t is equal to S over S squared plus omega squared. So, galing na yan dun sa ating first presentation, right? Sa bandang dulo, nandun yung mga formulas ng mga common Laplace transforms of different functions. So now the question becomes, what if this cosine omega t is multiplied by e to the at? So papaano yan? So kailangan lang tatandaan natin yung Laplace transform ng ating original function. So aalisin natin yung e to the at. Ang matitira lang dyan is yung cosine omega t. So, we now know that the Laplace transform of cosine omega t is this one. Therefore, ang sinasabi sa first shifting theorem is that papalitan daw natin, solve natin yung Laplace transform, and then papalitan natin yung S ng S minus A. So, in this case, ang makukuha natin is the Laplace transform of e to the at cosine omega t is equal to S minus A all over quantity S minus A squared plus omega squared, which is parehas dito sa first presentation natin sa lesson number 1. So, dito pinapakita na pag nagmumultiply tayo ng e to the at, A is a constant o any number yan. Pag nagmumultiply tayo ng e to the at sa ating mga functions, madali lang pala natin makuha yung kanyang Laplace transform. Hindi siya ganun kahirap. By using the first shifting theorem. Alright? So, that's it. So, subukan natin. Given this table, what is the Laplace transform of e to the at times t to the n? So, mapapansin natin na yung ating Laplace transform ng t to the n is equal to n factorial all over s raised to the n plus 1. So, papalitan lang natin yung ating s ng s minus a. Dahil nakita natin na meron tayong e to the at. Alright? So, ganyan lang siyang ina-apply yung ating s shifting. Okay? So, tatandaan lang natin, pag nakita natin yung e to the at or exponential function na na-multiply sa isang function, s shifting na yon agad. Alright? Next, we have the second shifting theorem or yung ating t shifting. So, in this theorem or in this property, sinasabi na if yung ating function is a shifted function, so that is defined in this particular equation. So, yung ating f of s is, yung kanyang t is na shift, yung kanyang time parang to the left and to the right by a constant a in this particular form, f of t minus a times the step function t to the minus a is equal to 0 pag yung t natin is less than 0, and the function, shifted function, pag yung t natin is greater than a. So, kung maaalala natin itong u to the a, u of t minus a, sinolve na natin yan doon sa ating first lesson, right? Yung example number 2, yung tinatawag nating step function or yung heaviside function. So, nalaman natin that the Laplace transform of this step function u of t minus a is equal to e to the minus as times a minus a over s. So, in this case, kung i-compare natin yan dito sa shifted function, we can say na yung ating f of t minus a dito is 1, right? So, with this, magkakaroon tayo ng analogy kung paano kinukuha yung Laplace transform ng mga shifted function, right? So, the question now becomes, what is the Laplace transform of a shifted function? So, the Laplace transform of a shifted function, given yung ating example sa lesson number 1, is that kukunin daw pala muna natin yung ating normal na Laplace transform for that f of t, and then i-multiply natin yan sa e to the minus sa. So, ganun lang siya kadaling isolve. Hindi siya mahirap. Ngayon, saan ba natin ginagamit itong mga shifted function? Okay? Marami sa mga equations na ginagamit natin sa different applications ng mathematics, meron discontinuity. So, itong shifting function, applicable to doon sa mga biglang tumatalon na equations. So, pag magkukuha tayo ng shifted function or Laplace transform ng mga shifted function, tatandaan lang natin, kukunin muna natin yung Laplace transform and then i-multiply natin yan sa e to the minus s. Alright? So, in other words, the Laplace transform of a shifted function f of t is equal to e to the minus as f of s. Alright? So, pakitandaan. Next. Okay, bago natin i-discuss yung ating next property, i-describe muna natin what is the term exponential order. Okay? We can say that a function f of t is of exponential order kung yung magnitude ng function na yon, absolute value of f of t is less than or equal to some exponential function m e to the ct for large number of t. So, approaching infinity for some m and c. So, constant yung m tsaka c dyan. So, ano ibig sabihin nito? Pag sobrang laki na ng t, yung ating function or magnitude na ating function will approach yung values ng m is less than the value of m e to the ct. Okay? So, importante yung value ng c dito sa equation na to. Therefore, okay, the limit as t approaches infinity of f of t over e to the ct, nag-exist yan for the exponential orders, okay, ng mga functions. So, in this regard, explain natin or discuss natin yung existence theorem. Okay? So, the existence theorem states that if a function f of t is continuous and exponential order with constant c, then merong Laplace transform yung function na yon na defined para sa lahat ng values ng s that is greater than c. Okay? So, illustrate natin yung theorem na to. Again, let's start with the definition ng Laplace transform. F of s is equal to the improper integral from 0 to infinity e to the minus a st times f of t dt. So we will now use this exponential order function m times e to the ct for the function f of t. So now, sabi sa existence theorem, magkakaroon daw tayo ng Laplace transform para sa mga exponential order na functions. Yun ay kung yung s natin is greater than dun sa c, which is in this case nasa exponent ng e. So dapat pala yung lahat ng s natin is greater than c. Okay? So solve lang natin. F of s is equal to m, dahil constant naman yan, the integral from 0 to infinity times e to the c minus s t dt. So ganyan na yung itsura niya, right? So i-evaluate na natin yung ating integral. So pag in-evaluate na natin, ganito yung lalabas. So m times e to the quantity c minus s t all over c minus s. Pag pinalitan natin ng infinity yung ating t sa una, no? At yung ating s is less than sa c. So ano mangyayari? Magiging e to the positive infinity dahil mas malaki yung c, right? So let's say 2 yung c, 1 lang yung s. So magiging positive infinity. So wala tayong makukuhang sagot. The Laplace transform will not exist kasi mas malaki yung c sa s. But if yung s is greater than c, then yung ating exponent ng e magiging negative infinity, which in this case, e to the negative infinity will become 0. Kaya sinasabi sa existence theorem na kaya lang nating mag-define ng Laplace transforms sa mga functions na continuous and exponential order kapag yung s natin is greater than c. So mag-e-exist lang ang ating Laplace transforms given these conditions. Okay, sana naintindihan yon. So isolve lang natin. So kapag ang s natin is greater than the value ng c, magiging e to the negative infinity, the limit of the function will exist, no? Magiging 0 siya. So pag sinubstitute naman natin yung 0 sa t, of course magiging 1 lang yung ating exponent. So that will be negative m over c minus s. So ano pa natin? Simplify pa natin, giving emphasis na dapat s is greater than c. Yung ating Laplace transform will now become m over s minus c. So, mapapansin naman natin yung ating formula ng exponential function e to the at, di ba? Parang ganito rin yung itsura. So, yan yung sinasabi ng existence theorem. So, mas ma-appreciate nyo yan pagka nagsasolve na tayo ng mga exponential orders, no? Kasi nalilimit na yung ating Laplace transforms, lalo pag yung c natin is greater than s. Okay? So, since we defined yung ating existence theorem, meron din tayong tinatawag na inverse. So, ang question in this particular case, kung nakakakuha tayo ng Laplace transform for a particular f of t, paano naman natin makukuha yung f of t pag given ang isang Laplace transform? So, yan ang question, which is important. Kasi, pag nagsasolve tayo, usually, nasa t naman talaga yung ating variable at wala sa s. But then, may ma-encounter tayong case na kailangan natin pabalikin yung ating sagot papunta sa t. So, the theorem behind this inverse is that for a given f of s or Laplace transform ng f of t, meron din siyang corresponding inverse, no? That we define the inverse Laplace transform to be f of t is equal to the squiggly L raised to the negative 1, or we call the inverse ng ating f of s. So, yan ang definition ng ating inverse Laplace transform. So, in the next few examples sa mga susunod na lessons, makikita natin kung paano gagamitin itong inverse Laplace transforms. So, we dedicated specific lesson sa pag-solve ng mga Laplace transforms. Okay, para mas ma-appreciate ninyo saan ba natin dapat kung paano mag-solve ng Laplace transforms. Okay? So, that's the end of this lesson, some properties of Laplace transforms. To sum it up, we discussed, or we can recall yung definition ng Laplace transforms. We discussed three properties of Laplace transforms. So we have the linearity theorem. So ginagamit natin yan for the combination ng mga functions. So ibig sabihin, distributive pala yung ating pagta-transform. Okay? Next, we discussed the shifting. So meron tayong dalawang klase. First, shifting theorem, and then yung second shifting theorem. So, diniscuss din natin yung pagkakaiba ng dalawa. And then, nagkaroon tayo ng mga konting examples. Third, we discuss yung existence theorem. Kung kailan nag-e-exist yung ating Laplace transform. Lalong-lalo na for continuous and exponential orders. And lastly, we discussed yung uniqueness. No? Kung paano natin maibabalik sa f of t yung ating, kung meron na tayong given na f of s. So, that's it. If you have questions, i-message nyo lang ako, and then we'll go to the next lesson. Okay? Maraming salamat. Thank you.